So now we're going to talk about what do you do when you have a radical or a square root in this case, and you have, number one, multiple things under the radical. What do you do? And then we're also going to talk about what do you do when you have variables underneath the radical. Okay, so the first thing is, if you look at this example, you've got several things underneath the radical. You don't just have a number anymore. So when that happens, what you want to do first is you actually want to break this into pieces. So however many things there are underneath the radical is how many pieces you're going to break it up into. So notice you have an 8. So you're going to just rewrite it as the square root of 8. Then you have an x to the 8th, and both of those go together because that exponent goes with the x. So you're going to kind of write it underneath its own radical, and you have to leave it underneath the radical because you haven't actually taken the square root yet. And then you have that y to the 2nd. So you're going to break that down into its own radical. And that way it kind of breaks it into pieces so that you can deal with one thing at a time. Okay? So in that last video, you learned how to simplify radicals like this. So if it is a perfect square, then you just take the square root of it like you normally would. But if not, then remember you had to break it down into two pieces. So you had to essentially find what is the biggest perfect square that goes into that. So if you needed to go to the side and write those out, you have like 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9. And then remember, once you get bigger than that number that's under the radical, you know you don't have to go anymore. So out of these two, what is the biggest perfect square that goes into it? And notice 4 is the biggest perfect square that goes into it. And then you kind of ask yourself, okay, what times 4 gives me 8? And so that would be 2. So there we go. Then you simplify. So you got the square root of 4, which is 2. And then you've got the square root of 2, which you can't simplify without getting a decimal. So that is what you get for the square root of 8. Okay, so now you deal with your variables. So when you have variables, there's actually two ways that you can do the problem. Okay, so one way when you have variables, and I'm just going to write it to the side over here. So when you have variables, one way to deal with it is you can think you're going to take, you're going to take the power, which is the exponent that you see, that's with the variable, and then you divide it by whatever the root is. So now in these examples, it's a square root, and so the number that goes with a square root is the number 2. So that's one way to do it, which I will show you. Or the other way that you could do it is kind of 2 steps. You're going to start by writing it out. So you write it out, and I'll show you what I mean by that. And then you're going to circle groups. Okay, so you can do it either way and it'll get you the same answer. Okay, so let's start by talking about what the power over root is. So if I was to do this one by thinking about it this way, what I'm going to do is I'm going to look at the power, which the exponent, which is the power, is 8. And then I'm going to look at the root, and it is a square root because it's just my typical square root. And so whenever I simplify it, I'm going to take x, because that's the variable I'm dealing with, take the power of it, which is 8, and divide by what my root is. So I take that 8 and I divide by, well, a square root is associated with the number 2. And so I just take those and I divide them. So what is 8 divided by 2? Well, 8 divided by 2 gives me 4. And so the answer that I'd get when I take the square root of x to the 8th would be x to the 4th. Okay? Now, if that did not evenly go into it, if you had like a remainder, then that means that you would leave that many x's underneath the radical, which we will do one of those in just a minute, okay? So that's one way to do it. The other way that you could have done this one is writing it out. So I'll show you what I mean by that. So if you took that same problem and you wrote it out, x to the 8th means that you technically have x times itself 8 times. So you would write x times itself 8 times. So x times x times x times x until you get 8 of them written out. Kind of like that. Okay, so x times itself 8 times. All right. So that is actually the exact same thing as this right here. And then what I mean by circle groups is whatever the square root is, you are going to circle groups of that many. So like the square root is associated with a 2, so you're going to go in and you're going to circle groups of 2x's. So there's a group of 2, that's a group of 2, that's a group of 2, and that's a group of 2. And then when you're done, however many groups you ended up with is actually going to be the exponent of that variable that would come out. So I was able to make 4 groups, so that when I take the square root of that, it would actually end up being x to the 4th power, because there's 4 groups. So that actually becomes the exponent. And notice that's the same thing we ended up with by doing it the other way. So either way will get you the same answer, okay? So that's what we got there. So this one, you can decide whatever you would like to do. You could do power over root or write it out in circle groups. So like if I wrote this one out, it'd be the square root of y times itself 2 times. It's a square root, so I'm circling groups of 2. Figure out how many groups you were able to make. I was only able to make 1, so whenever I write my answer, it'd be that variable to the power, and the power would be how many groups you can make. So since I was only able to make 1, it's going to be y to the 1st power, okay? So whatever your answers are, I actually call like your mini answers, okay? So to actually kind of put this all together, what would be the square root of all of that? Anything that's on the outside of the radical goes together. So like my 2, my x to the 4th, and my y are all on the outside of the radical. So we put those all kind of together outside. And then anything that ended up underneath the radical still is going to stay underneath the radical. You just write it kind of at the end, okay? And then that was the only thing that stayed underneath the radical. So there is our answer. So that would be what we would get if we took the square root of that, okay? So let's do another one. So with this one, we've got the square root of 20, and then we have the square root of x to the 3rd, because there's 2 things. So you break it up, square root of 20, square root of x to the 3rd, and then you simplify. So this one is not a perfect square, so just like the one before, we've got to break it up. So break it up into your 2 squares, or square roots, and then you ask yourself, what is the biggest perfect square that'll go into that? So if you needed to write out your perfect squares again, you can, or you could just kind of sit here and think, okay, I got 1, 4, 9, 16, 25. What out of all of those is the biggest one that'll go into 20? And if you sit there and think about it and kind of play around with the numbers long enough, you'll figure out 4 is the biggest one that'll go into it. And then you ask yourself, okay, what times 4 gives me 20? And so you could just take 20 and divide it by 4, and you'll figure out you get 5. Okay, so then we simplify. So square root of 4 ends up being 2. Square root of 5 won't break down, so it just comes down. So this is kind of like a mini answer to the problem, because that's part of your answer. That's what you got when you took the square root of the 20. And now we have to do the square root of x to the 3rd. So either you do power over root, or you write it out in circle groups. So like if I was to do power over root for this one, I would take x to the power is 3, the root is the square root, so it'd be 2, and then I divide. So this is one where I'm going to end up with a remainder. So how many full times does 2 go into 3? And it goes once, and then how many are you going to have left over? However many full times it goes into it, like notice it only goes once, is how many x's you pull out of the radical, so it'd be x. And then however many you have remaining, like if I divide 2 into that, I'm going to have 1 left over. That's actually how many x's stay underneath the radical, okay? So if you're doing power over root, that's how that works. If you were to write this out and do it that way, you'd end up with 3 x's underneath the radical. And so it's a square root, so you circle groups of 2. So I have 1 group of 2, and then I don't have enough to make another one. So however many groups you have is what you pull out, and that'll be the exponent of what you pull out. So I ended up with 1 group, so it'd be x to the 1st that I take out of my radical. And then I had one that I couldn't make a group with. So that one has to stay underneath. So notice, either way you do it, you get the same answer, okay? So here's part of my answer. This would be the other part. And then you just put them together. So to put it together to get my final answer, you take the outside numbers or the outside stuff and put it together. So I've got the 2, and then that x to the first is outside, so it goes outside of the radical. And then, like I said before, anything that was left underneath the radical you put together, and you kind of put it at the end. So we've got the square root. You still have to put the square root because you can't take the square root of these. So the 5 would go underneath, and then that x would go underneath as well. And so when I take the square root of 20x to the third, I would get 2x square root of 5x. That would be my answer. Okay, so let's do one more. What if we had something like this? Well, think about how many different things would you have to break it up into. And so notice you got the 40, so you got square root of 40. You've got the x to the 10th, so square root of x to the 10th. And then you have the y to the 5th, so it'd be square root of y to the 5th. Okay, then just like you did before, you start working each one separately and then put them together. So square root of 40, that's not a perfect square, so you got to break it down. You got square root and square root. All right, what's the biggest perfect square that goes into 40? So think about it. What is the biggest perfect square? And it's actually 4. And then 4 times 10 gives me 40, because there's not a bigger perfect square that will evenly go into it. So it actually ended up being the 4 as well. What a coincidence. All of them had the 4 as the biggest perfect square. Then you simplify. Square root of 4 is 2. And then the square root of 10 won't break down anymore. So that's kind of like a mini answer. So just circle it so it kind of stands out so that you can put it together in a minute with the other answers. And then this one, same story. You can write it out, or you could do power over root. So if I did this one with power over root, it'd be x to the power is 10. The root, it's a square root, so you'd put it over a 2, and then you divide it out. However many full times it goes into it is the exponent that you would have left. So it'd be x to the 10 divided by 2. It actually goes into it evenly. So you would have x to the 5th, and there's not a remainder, so you don't have any, like in the last problem, you wouldn't have any that stays underneath the radical, okay? So that's part of that one. And then this one, same story. You could do power over root, or if it helps you better to write it out, we could write it out. You'd end up with 5 y's, because it's y to the 5th, so 1, 2, 3, 4, 5, and then a square root, you're circling groups of 2, so that's a group, and then you have 1 left over. So you're going to have 2 groups, so it'd be y to the 2nd, because you had 2 groups, and then you have 1 that you couldn't make a group with, so it just stays underneath. And so there's that one. And then you just put it all together. So anything on the outside goes together. So on the outside we'd have a 2, x to the 5th, y squared. And then on the inside you had a square root of 10, and then you had a square root of y. So you put those together underneath the radical. So it'd be a 10 and y. So that is what you get when you simplify this. And remember, with simplifying radicals, you do not want to end up with a decimal. So there you go.